Before we start the class, kindly someone please lead a prayer. Yes, Mr. Wilson. Good morning, class. Before we continue, please make sure that there is no trash around your area and that you are sitting properly. Okay? So, Mr. Secretary, do we have any students who are not with us today? That's good. So, what was our topic last meeting? Anyone? Yes, Mr. Michael. Very good. We talked about the Cartesian plane, which consists of perpendicular lines. The horizontal line, which is our x-axis, and the vertical line, which is our y-axis. And do not forget the intersection between them, which is the origin. Also, class, we've discussed about the quadrants, the four quadrants of the Cartesian plane. The first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. And each quadrant have a specific sign to each values. And what is the sign to each values on each quadrants? Yes, Miss Angel. Very good. The first quadrant, we have the positive. The second quadrant, we have the negative, positive. The third quadrant, which is negative, negative. And the fourth quadrant, which is positive, negative. Class, you should remember everything. You should remember about the Cartesian plane, the quadrants, and also the specific sign to each quadrants, because we will be using this later on to our topic. So, before we proceed to our topic, we will have a very simple activity. It is a simple activity, class, that you just need to answer using your illustration board. Did everyone bring their illustration board and a chalk? Very good. You will write your answer to your illustration board and raise it so I can see if your answers is correct. However, class, you should be faster than the other students. Why? Because the last students who will raise their answer or got the incorrect answer will have a very simple consequence. That consequence is that you need to dance with the music of the TikTok dance. So, you just need to dance in person, that is not in phone. So, let's start the game. So, number 1, 68 minus 59. Very good, 9. 79 minus 187. Very good, negative 108. The absolute value of negative 5 minus 5? Positive 10. The absolute value of 12 minus 10? Positive 2. The square root of 144? Positive 12. The square root of negative 1 minus negative 5? Positive 2. And lastly, the square root of 6 squared plus 8 squared. Very good, positive 10. So what did you notice to the questions, class? You will notice that we did find the difference of the two numbers. We also get the absolute value of the difference of the two numbers, which is the absolute value makes the answers always positive. Very good. And also we got the square root of a number. You should know how to square root, class, because later on we will be using more and more square root to our solution. So if you will notice, class, these are the basic operations. And these basic operations were necessary to our topic for today, which is all about the distance formula. So, our learning objectives for today will be to illustrate the distance formula, to discuss the formula for finding the distance of the 2 points, and lastly is to apply the distance formula in real life problems. So, in getting the distance of the 2 points, which is um, in a straight line, you will need to get the difference, which makes the word difference is equivalent or equal to the word subtract. So you will need to subtract the second point to the first point to get the distance between them. So let me give you an example. In a straight line, we have the midpoint, which is the 0, and we have the -5, our A, and the +5, our B. What will be the distance between them? Yes, Mr. Lawrence. Very good. 10. There's a two-way to get the distance between them. You can count from here in -5 to the +5. However, you can use also the formula that we know, which is to get the difference of the 2 points. The point B, which is 5 minus -5. Simplify. 5 negative times negative will be positive. Then 5 plus 5 will be +10. However, class, what if we interchange their values? What if the value of B is the -5 and the value of A is +5? What will be the answer, class? Very good, -10. -10, because if we put it in an equation, we have the -5 minus +5, which is, they are both negative, so we will add them 10, then copy the sign negative. However, class, I want you to remember this, that in getting the distance, there is no negative distance. The distance will always positive. Okay, class? Let me ask you a question. Can you go to your school from your home while walking backwards? You can't, right? That's why there is no negative distance. We always move forward. In the distance, we always move forward and not backwards. It also applies in many things. That's why the answer will be the absolute value. We will always put absolute value. And if there's absolute value, that means that the answer will always be positive. That's why this will be +10. This will be easy for you, class, because it is only a 2 point that is in straight line. However, what if we are getting the distance that is in Cartesian plane? So we have an example for our point A. We have the 4, 5, 3. Point A is 5, 3, which is in quadrant A. -5 and 3, which is in quadrant 2. And if you look to the given, they form a straight line. And what do we call this straight line? Yes, Miss Raisa. Very good. They form a horizontal line that is parallel to the x-axis. So it means that if it forms a horizontal line, then the distance will be the difference of the x values. So we have the x sub 2. We have the x sub 2 minus x sub 1. If the line formed is horizontal. Then what if the line formed a vertical? What will be the equation? Yes, Miss Roxanne. Very good. We will use the difference of the y values. Y sub 2 minus y sub 1. Remember this formula, guys, class. Okay. So back to the example. They form a horizontal line, so we get the difference between their x values. Then the negative 5 minus 5 will be negative 10, which is the absolute value of negative 10 is positive 10. That is correct. So the answer will be 10. The distance from negative 5,3 to 5,3 is 10. You can also check it by counting. Then what if we have the vertical line? This. We have the given of 3,1 here and 3,7 here. What is their distance to each other? Yes, Mr. Jason. Very good. That will be 6. You just need to find the difference of their y values, which is 7 minus 1. Because the 7 is our y sub 2 and 1 is the y sub 1. So 7 minus 1 is 6. Just like that. So let's move on to our most important question for today, which is how can we find the distance between any 2 points? Focus on the word any 2 points. Excuse me. Focus on the word of any 2 points. It means that we will find the distance between any 2 points that is plotted everywhere in the Cartesian plane. It can be here, from here, can be here, everywhere on the Cartesian plane. Then how we get the distance between them? I will give you a hint what formula we will be used to get the distance between them. The formula is the formula for getting the side of a triangle. Yes, Mr. Aaron. Very good. That is the Pythagorean theorem. And what is the formula for Pythagorean theorem? Very good. It is the c squared is equal to a squared plus b squared. However, class, we cannot use this just like this in getting the distance of any 2 points. We need to derive it first. We know that in getting the distance of the horizontal lines, we need to get the difference of the x sub 2 minus x sub 1. In vertical lines, we get the difference of the y sub 2 minus y sub 1. This formula that we got earlier will be in our distance formula. So how? So we have the Pythagorean theorem, which is c squared equals to a squared plus b squared, right? Then substitute the value. The c will be d because d stands for distance. The a will be the difference of the x values, which is x sub 2 minus x sub 1 squared, plus for v, the difference of the y values. Very good. Y sub 2 minus y sub 1 squared. Because class, why we use the formula for the horizontal and the vertical? Because the distance formula is used to get the distance of the 2 points that is diagonally away from each other. That is why. So b squared Both sides, cancel 2, cancel square root. D will be the square root of the x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And this will be the distance formula. Here, how we derive the formula from the Pythagorean theorem to the distance formula. So now we can define the distance formula as an algebraic expression that gives the distance between pair of points in terms of their coordinate, where the formula for the distance was derived on the Pythagorean theorem. So to fully understand the distance formula, we will use it in an example. So we have the point P and point Q. So our point P is 2 and negative 2, which is the second. The y values is negative, therefore this will be in quadrant 4. The point Q is 6, 1. It will be in quadrant 1. If you will notice, class, that their coordinates are different to each other. That's why we will use the distance formula to get their distance to each other. So, using the distance formula, we substitute the value. What is the x sub 2, class? 6 minus the x sub 1 is 2 squared plus y sub 2 is 1 minus the negative 2, which is our y sub 1 squared. So, simplify. 6 minus 2 is 4 squared plus negative times negative is positive. So 1 plus 2 will be 3 squared. So distance will be the square root of 4 squared is 16 plus 3 squared is 9, which makes it will be the square root of 25. That the distance will be positive 5. And that is their distance to each other. Do you understand, class? It is very simple, class. You just need to remember the distance formula. And you can get the distance everywhere in the Cartesian plane. Next example, how about the 1 point or the given that we have is from the origin to the 8 point that is in first quadrant. What will be the distance? Yes, Mr. Lawrence. Yes, Mr. Lawrence. Very good. That will be positive 5. How? Using the distance formula, we substitute the value, then we will get the positive 5. However, we can get the answer without doing the exact formula for the distance. We just need to use this formula, which is the square root of x squared plus y squared, because the given or the coordinates of the first point is only a 0, so you just need to square the other point and you will get the 5. Okay? So, for our last example for today, this is based on experience. So, I have a girl that I like, but she's so far away from me. So I did try to find my distance to her. So I put my coordinates in the fourth tree, here in the first quadrant, while she was in negative 4 and negative 3, which is in quadrant 3. So can you give me the distance, or can you give me how far she is to me? I want everyone to answer this problem. I want you to put your answers in your illustration board and raise it When I count 1 to 3, everyone will raise your answers, okay? So, 1, 2, 3. Raise your answer, class. Very good. The answer is 10. That's how far she is to me. But this 10, I know I can get rid of it just to see her. So, is there any questions regarding our topic for today? Any concerns? That's good. I am very glad that you all learned about it. So, for our topic for today, I would like you to group yourselves into 10 groups and which consists of 5 members class. I will give each group this paper which has the picture of the dasma that is plotted, that is in Cartesian plane. And if you'll notice class, there's a 1 point in there, given point. And that given point is the location, is our location right now. So I want you to point anywhere in the dasma you would like, or you know a place. Then get the coordinates of it. Then connect it to our location right now. And if you connect it, you need to get the distance between them. So this will be a 3 point each class, 3 point each distance you will get. The more you put a distance, the more you get the scores. So 1 point for coordinates, 1 point for the answer, and 1 point for the solution. So 3 points each. Put your answers in a one whole bond paper. I will give you only 8 minutes to finish that activity. You may start now, class. So for our evaluation, we have here questions. So in a 1/4 sheet of paper, find the distance between the given points. Choose the best correct answers. I will only give you 5 minutes for this class. You may start now, class. So, for our assignment, I would like you to have a copy of your municipal, city, or province. Put it in a Cartesian plane, then indicate some important landmarks, and also explain why you choose it. It will just be like our activity for today, but put it in a 1/2 illustration board, and you will pass it to me tomorrow. So, to conclude everything that we have discussed today, the distance formula is used to find the distance of any 2 points that is plotted in the coordinate planes or the Cartesian planes. However, it is not limited only to this Cartesian plane. It can be used also in a real life situation, just like how we find the distance between me and to my girl, or a distance of a place to one another. You can use anywhere the distance formula. So that will be all for today. I hope you learned something, and I'm very glad that you are all with me today. Okay, goodbye, class.